Hello and welcome to my bi-weekly video log. Today in Only Production Exists, I'm talking about how meaningful our testing is and how we can be cognizant of what the limits of testing are so we can decide how to best spend our time and resources to build the best quality software that we can. One thing that we know is that software is rarely static. There's almost no such thing as software that never needs an update, never needs changing. Maybe there's some old system chundering away in a bank somewhere, but logically, it's almost certainly got bugs in it somewhere. As such, we must always be making changes to our products. Here's an example of just a few of the kinds of changes we might make. We might be making changes to the code, to the infrastructure, to resources. We might be updating versions, security patches, rollbacks, scale up, scale down, scale in, scale out, shake it all about. But there's lots of types of software product. There's web apps, mobile apps, games, desktop software, middleware, embedded systems, hospital equipment. There's so much. So I'm just trying to be as generic as possible. Here's just a few of the types of changes we might make in our roles. But don't stress if these don't fit scenarios that are relevant to you. But the universal thing is that when we make a change, there's one critical question we ask prior to making or deploying or applying that change. Has it been tested? So that's a really reasonable question. Let's say we've got a system and we want to make a change to it. It could be a database rollout, it could be any of the aforementioned things. We want to have some confidence that that change is safe, but let's be a little bit more precise. How has it been tested? There's tested and there's tested. It works on my machine, hasn't been good enough for decades now. In fact, it never has been. So what we tend to do for a lot of changes is have some kind of simulacrum of what we'll call the production system, the real system, something that we can verify our change in. And as such, a common pattern is the staging environment. Now, this could look like a number of things, but let's take the classic example. Your classic like three-tier web app architecture. If this doesn't fit your use case, don't worry about it. This is just an example. We would first test a change in staging and then test in production. We would do that for a lot of reasons, but mainly so we can build confidence that we're not disrupting our users and therefore our business. So if it goes wrong in staging, great, valuable lesson, and we can regroup without incurring massive loss. There are innumerable ways this might look. Here's an example of in a Kubernetes cluster with multiple namespaces. Maybe there's a namespace that's like the test version here, so it's running on pretty much the same hardware. I don't really want to get hung up on specifics. What we're saying is we have a production system and a similarly configured system that we use to try out our changes. It could be a couple of Raspberry Pis on my desk. It doesn't matter. I'm just talking about there's a real system and then there's a simulacrum thereof. And what I want to get into is what are the limitations of this kind of staging-based, simulacrum-based approach. So what we'd naturally first think about in considering the limitations of staging systems is that there's a lot of potential difference there, what we would call the delta, because cost can come into play. It doesn't always make sense to run a staging environment at production scale. You might stub out some services, you might have a smaller database, you might have fewer pods running, whatever your configuration is. And even if you do configure it identically, which might well be a waste of money, and it might not, you might not have the same configuration. At the very least, you're probably going to have some different DNS entries or a different database name or something will be different. Now, this delta is important and it is salient, but it's not the main thing I'm pressing on here. And I'll get to what I'm actually talking about very, very soon, I promise. But even if staging isn't a toy version, even if it has fully mirrored traffic from production and identical configuration via IAC, infrastructure as code, and you're as close as darn it to the production system, there's another critical distinction I think we must bear in mind. So to frame that distinction, let's go fully abstract. So consider these two patterns. At first glance, they look more or less identical, but let's overlay one on the other. They're subtly different. Well, so what? We'll come back to this. Let's have a more concrete example. Let's say that you own this car, Mr. Bean's car, and you want to do some work on it, but you don't know what the effect of that work is going to be. So it's not very useful to use the car on the left to work on it. It's not a useful proxy. So you get another one of the same model to work on. Now, even if those cars look identical, even the same model, even if the same Burke sits on the roof, they're not technically the same car. By working on the car on the left, I might be able to learn something about the likely behavior of the car on the right. I might make a bunch of mistakes on the left and then learn a lot It's a good thing to do, but it isn't the car on the right. Let's go a fully concrete example. A friend at church had a faulty Walkman. It was very precious to her from her childhood, and she asked me to fix it, so I agreed. But before opening it up, I bought 3 identical models from eBay and opened them up to practice on. And I broke 2 of them before I got the hang of the particular layouts. When it's pretty fiddly in there. But it was really beneficial because I learnt the ins and outs of the device. However, there was only one of these units that was precious to my friend at church and had her, childhood fingerprints on it, if you like. The 3 that I bought to test, they were not the thing itself. They were simulacrums. So we have, in the first example, some squiggles that look identical, but they're not. Staging systems might appear to be identically configured, but have subtle differences, even if you've gone as far as infrastructure as code, traffic mirroring, trying to get it as near as you can. In the second example, we've got 2 cars that are the same model, but you can think of them as like 2 different tokens of the same type. And likewise, the Walkman example, there's only one real deal that actually matters to people, and that's the real thing. So that's how I view staging environments. They might be similar, but they're not likely to be functionally identical. And even if they are functionally identical, then they'll have different usage profiles and amounts of load. And even if you mirror the traffic so that that's the same, it's going to have some differences. And even if we normalize the URLs somehow through like DNS masking, the staging system is not the same instantiation of the system as production, even if configured identically. So let's put it in more precise categories. Staging and production are isomorphic, but they're not identical. So staging might have all the right shapes, but it hasn't got the essence. In mathematics, isomorphism means it's structurally the same, but not actually the same. Or staging is structurally similar to prod, but it's not the same system. So we might think of staging as a counterfactual twin, a model of production, what it might be like under certain conditions. So is this actually useful to know, or is this just waffle? Well, consider the effort we might put into our staging systems. Think about over time, we're putting in more and more effort. We're taking it from useless to a perfect replica. But you're going to asymptotically approach perfection. It's never going to be the same system. And you're going to hit an inflection point where the model is, it's good enough for most use cases. Because that's what it is. I mean, George Box said, all models are wrong, but some are useful. And staging systems, you might call it integration, you might call it development, you might call it test, whatever it's called. Doesn't matter. Very useful model. They are useful. I'm not denying that. But what I'm talking about here is making sure we understand the limitations as well as advantages of using this approach. And once we've hit this inflection point where we're putting into effort to make it look the same, this inflection point might be cost, it might be effort, it might be time. But at some point, we just got to kind of say, right, this is good enough to model stuff in, but we have to see it for what it is. Otherwise, we risk target fixation, which is a psychological phenomenon where somebody becomes so focused on an outcome that they actually end up steering towards it. So that might be like you see a pothole and you're like, I better not hit that, better not hit that, better not hit that, and you hit it. It actually makes you more likely to collide with it if you get into that frame of mind. So if we fixate on achieving perfect parity between staging and production, that's kind of a form of target fixation. We get so focused on the staging fidelity, which is a proxy, remember, it's not the real artifact, that we actually unintentionally steer the team away from the real business goals or organizational goals or project goals, like shipping faster, measuring impact, observing behavior, delivering features, whatever it is we're actually trying to do. We're getting in our own way by getting too obsessed with making this thing perfect when it never logically can be. So there's diminishing returns as well. It can cost a lot of money to keep a production-like environment fully spun up, right? So rather than getting target fixated on the most perfect staging environment ever, here we can use complementary strategies, things that work alongside testing in lower environments. So not all products are different. Not all strategies are appropriate everywhere. These are just some examples. Like these aren't the thing themselves. What I'm trying to get at is the artificiality of testing and staging doesn't mean it's not useful, but we can also put effort into reducing costs of change via automation and using LLMs by adding feature flags so we can flip things on and off and even canarying them on and off to groups of users. We can invest in our observability, making sure that we know about problems before our users do. We can mirror traffic so we can see how it behaves in our staging system. And we can look into self-healing systems. There's a lot more I could have listed here. They're just some examples of things we could be working on when we're scrabbling, try to get the most perfect staging system ever. So We might then ask, well, should we even have staging environments? And generally, yeah, it depends on the project. I'm not suggesting at all we get rid of them. They're very, very powerful tools. All I'm saying is we need to be aware of their limitations. They're absolutely life-saving for testing infra and code changes and building confidence. It's never proof. It's never verification. It's only building confidence. Like a unit test, it builds confidence. It's not a mathematical proof necessarily. But they don't make it absolutely certain a given change will work. And ultimately, it's all about how do we pressure test our assumptions. So yes, we've got a test. We do everything as like for like as we can in a way that doesn't affect our users. But we just have to remember staging is a simulacrum of production. It imitates and resembles it structurally, but it is not the thing itself, and it never can be. It's a highly useful model, very useful. And we have other concerns other than creating some unachievable parity with the staging environment, because after all, only production truly exists. So thank you so much for tuning in. I hope you found it interesting. And these videos aren't necessarily about my main areas of expertise, but they're my areas of growth right now. And if you've enjoyed this video, have a look around the rest of the channel. Thank you very much.